Welcome to a tutorial on digital electronics, and in this tutorial what we're going to do is we're going to show you, or rather we're going to discuss about the encoders. Okay, so the encoders, as you see, well, they are a certain type of digital device, okay, and they come under the head of combinational logic circuits in in digital electronics. Okay, so basically what the encoders do is that they whenever in case of the encoders, they have a certain number of input lines, okay, and a certain number of output lines. Okay, so with whichever input line we would select on an encoder, okay, it would output that particular selected line's corresponding binary code at its outputs. Okay, so just before we move on to the details about the encoder operation, for the time being, just consider that this square box that I'm showing you over here represents the circuit of an encoder. Okay, so this is our encoder. All right, so the encoder's input and output lines have a certain relationship between them. Okay, so if, let's say, we consider that here n, let's say, or rather, yeah, let's say n represents the number of output lines. Okay, if it represents the number of output lines in the encoder under discussion, and m represents the number of input lines in the encoder under discussion. So basically what would happen is that the number of input lines of the encoder, okay, and the number of output lines are connected by a mathematical relationship, which could be summarized somewhat this way. Okay, so we see here that the total number of input lines of an encoder, okay, rather the maximum number of input lines of an encoder is equals to 2 to the power the total number of output lines of the encoder. Okay, so if an encoder let's say if it has let's say 4 input lines, then it would have 2 output lines. All right, and if the encoder has, let's say, 8 input lines, then it would have 3 output lines. Okay, so and so on. This just would go on and on depending upon the number of input lines that the encoder under discussion should have. Okay, so coming back to the discussion on the encoder operation. So let's just for the moment assume that our encoder has, let's say, 4 input lines, so that way it would be a little short and precise. You wouldn't feel bored, as it requires some less amount of time. Okay, so here I draw 4 input lines to our encoder. All right, so here let the lines be named as, let's say, we name it this way. Let this be the I0. Okay, this is I1, this is I2, and the last one, that's the 4th one, is let's say we name it as I3. Okay, so these are the various input lines on the encoder. Okay, and corresponding to the 4 input lines in the encoder, it should have 2 output lines. So basically these are the 2 output lines of the encoder. Let them be named as, let's say, Y1 and Y0. Okay, so here you can see our encoder under discussion has 4 input lines and 2 output lines. So based on that, it will be named as a 4 to 2 encoder. Okay, I have a problem with the E's. All right, so this 4 to 2 encoder, okay, represents an encoder with having 4 input lines, which is mentioned first, and 2 output lines that's mentioned in the next after the first digit. Okay, so that's basically about how an encoder is named, and the size of the encoder is basically pointed out by naming the encoder in terms of its number of input and output lines. Okay, so basically if we just try to discuss about the encoder operation. Okay, let me just in order to do that, I will need to draw a truth table. Okay, so here's our truth table. Okay, so let's say we have on the left the inputs, okay, and on the right we have, let's say, the outputs. Yeah, right. So in the input part, let me just write it down. Let's say I write it down. Let's say this is I3, this is I2, I1, and I0. Okay, and at the outputs, let's say use a different color over here. We have Y1 and Y0. Okay, so let me just mention before that the Y1 over here, since the encoder outputs a binary code, so this term Y1 would be the MSB of the binary code output from the encoder, while Y0 would represent the LSB of the binary code output from the encoder itself. Okay, so keeping that in mind, we write it down this way. Okay, so now when we have let's say I'll use a different color this time. Okay, fine. So when we would have let's say, or rather just select any of these any input line out of the 4 input lines that are present on the encoder. Let's say I select line I0. Okay, now the selection of the lines is brought about by applying a logic 1 signal to the respective line that we want to select. So if I want to select line I0, so I would provide a logic 1 signal. Okay, that's a logic high signal at I0. So here I put 1. Okay, so I0 is set at logic 1 state. Okay, while the rest of the input lines are set at logic 0 state. So under this condition, what we have is that we would get an output code that would read somewhat this way: 0 0. So what does this basically mean? This basically means that we're getting a binary code output. Okay, since there are 2 output lines over here, therefore excuse me, that's a problem with throat. I'm having cold right now, so don't mind at that. So let's just come back to the encoder operation again. Okay, so where we left our discussion is that our encoder over here, since it has 2 output lines, so it can output a maximum of 2-bit binary code. Okay, so the output binary code would have a maximum of 2 bits. Okay, so here, corresponding to the decimal notation of the input line to which we had selected, that is I0, whose decimal notation is obviously 0. So corresponding to that, okay, we can get a binary code. All right, we can get a binary code output. So basically 0 in terms of decimal is represented as 00 in terms of 2-bit binary system. Okay, so having that said, let us now select line I1. So I apply a logic 1 signal at I1 and keep the rest at logic 0, since there are no, since the other lines are not selected at all. So for the decimal notation, for the decimal value of 1, the binary code output would be 0 1 in terms of 2-bit binary system. Okay, again, now if we just try and select line I2 right now, okay, applying a logic high signal over here, we would obtain a binary code output of 1 0. And finally, for selecting line I3, applying a logic high signal at I3, okay, we would obtain a binary code output of 1 1. So for 3, we see the binary corresponding 2-bit binary code is 1 1. For 2, it is 1 0, for 1 it's 0 1, and for 0 it is 0 0. So that's how we obtain the specific, or rather corresponding binary code of the input line that we select, and the binary code that we obtain by selecting a line is just the equivalent binary code of its decimal notation. Okay, so that's how an encoder basically works. All right, so now if you all are interested in constructing an encoder out of, basically you'll be, introduced into the study of encoders by, through constructing them with digital circuits, or rather with logic gates. So if you all are planning to construct an encoder with logic gates, this is how you should do it. Okay, here is the diagram for constructing an encoder with logic gates. So basically what we see here is that this is a typical example of the 4 to 2 encoder that I've been discussing about over here. So when in this encoder we just need 2 OR gates, okay, in order to construct this encoder, and the wiring is done pretty much in this way that is shown in the diagram. Okay, notice that whenever we set the line I0 to the logic high signal, the output at the truth table over here is 0 0, which is also shown in this truth table. Okay, so for putting I0 at logic high signal, we obtain an output of 0 0. So that means the the voltage levels at the 2 output terminals are both at the logic low state. So therefore the I0 line is not connected to any of the OR gates, as you can see here, since we would obtain a output of 0 0 anyway. So it doesn't matter as such. So this is basically the wiring that would be required to construct the circuit of a 4 to 2 encoder by means of using logic gates only. And here is the truth table, which I have already demonstrated over here. Okay. So having that said, the encoders that are, if you just need to apply an encoder to for a specific application, so constructing the encoder using logic gates would be a very laborious process as such. So basically, due to that reason, the engineers thought of making such chips instead, okay, microchips. Within which the entire circuit of this encoder would be made. So basically there are various types of encoders, like the 74154 encoder, okay, and several others. Okay, I don't remember all the names right now. Okay, so if you just check on the internet for the names of various types of encoder ICs, okay, then you would obviously find them depending upon their sizes and specifications. Okay, so the 74154 IC that I've been talking about over here is an encoder IC in which is obviously a 8 to 3 encoder. Okay, so in this IC we have 8 inputs and 3 outputs. Okay, so this is basically an 8 to 3 encoder. Okay, other than this, there are several types of other encoder ICs also available. So if you need, you can just check on the internet, as I said before. So having said all that, we just come to the end of our discussion on encoders and their operation and principle. I hope you've learned about how the encoders work. So kindly check out our tutorial, next tutorial in the digital electronics section. Okay, so till then, it's thank you for now and goodbye.